Need a reliable way to move AI agents, models, and data through environments without breaking governance or consistency? Hi, and welcome. I'm Georgia, lead technical trainer at Microsoft, and in this session we'll cover Application Lifecycle Management across multiple Microsoft services. Together, we will explore a practical, structured framework to bridge the gap between innovation and operational discipline. Let's get started. By the end of this video, you'll be able to design ALM processes for AI components like datasets, prompts, and models, establish governance, security, and monitoring across environments, and ensure consistent, compliant AI behavior from development to production. Let's start with designing the ALM, Application Lifecycle Management, process for data used in AI models and agents. Data is the foundation of every AI solution. If your data is ungoverned, your AI is ungoverned. The first step is scoping what we mean by data in AI ALM. It is broader than you might think. You need to treat all of these as versioned promotable artifacts, training and fine-tuning datasets, evaluation and golden test sets for regression, grounding knowledge from sources like SharePoint or Dataverse, prompt assets including system prompts and templates, policies and guardrails like DLP and sensitivity labels, and finally, run telemetry including latency, token costs, and safety events. Your best practice is to ensure every one of these is tracked, versioned, and governed, just like application code. This is the foundation of reliable AI. Your environment strategy for AI data is very important. Create separate data planes for each environment: dev, test, pre-prod, and production. Each one must enforce least privilege access with no shared identity across environments. Use the red gold datasets pattern. Red datasets are mutable and experimental in dev, while gold datasets are frozen and promoted for production use. Every promotion gate between environments requires evidence, including quality reports, bias checks, lineage documentation, and security sign-off. Controls at its top include validation, approval, immutable snapshot creation, and catalog updates. This separation is what prevents experimental data from contaminating production. Phase A is all about planning and cataloging. Before any data flows into your AI pipeline, you need to identify your business scenarios and establish data contracts that define purpose, fields, retention policies, and owners. Classify sensitivity and apply sensitivity labels, then register all assets in a central catalog so they are discoverable. Define your KPIs and risk posture, covering PII handling, export boundaries, and audit scope. The gate from Phase A to Phase B is clear. Data contracts must be approved and assets must be discoverable with assigned owners and tags. Without this foundation, everything downstream becomes ungoverned. Phase B is where you ingest and prepare your data. Start by profiling and remediating quality issues like outliers and class imbalance. Generate lineage records and stamp schema versions and hashes for every snapshot, so you always know exactly what data you're working with. Produce curated datasets and feature or embedding sets using deterministic pipelines, which means the same inputs always produce the same outputs. The gate from B to C requires quality and lineage reports, plus a signed reproducibility log. If you cannot reproduce your data, you cannot trust your model. Phase C is where development and evaluation happen. Train and iterate using dev and test data. But here is a critical rule: never train on production knowledge. That would compromise the integrity of your evaluation. Run evaluation suits on golden datasets covering accuracy, safety, robustness, and cost. Store model and data cards with dataset references and context limits so anyone can understand what went into the model. The gate from C to D requires that evaluation thresholds are met and all risk and safety findings are addressed. This discipline ensures your model is ready for the real-world scrutiny of staging. Phase D is the staging and approval checkpoints. This is where you perform privacy, security, and compliance reviews, including DLP, responsible AI assessments, and export controls. Execute runs using masked or representative production like data. Canary testing is a low-risk deployment strategy that releases changes to a small, isolated subset first to identify issues before full rollout. Freeze your gold datasets and sign immutability at the stations so nothing changes after this point. The gate from D to E requires Change Advisory Board approval, plus deployment runbooks and rollback plans. Phase E is deployment and serving. Now you promote your gold dataset and indexes into production and refresh semantic indexing or retrieval stores. Enforce region and residency settings and connector allow deny lists so data stays where it is supposed to be. Register the release in your data catalog and publish consumer contracts so downstream teams know exactly what is available and how to use it. Your best practice here is to make every deployment traceable. Anyone should be able to look up what was deployed, when, and with what data at any point in the future. Phase F is where you operate and monitor your AI in production. Track key metrics including latency at the 95th percentile, cost per token, success rate, safety violations, and data access denials. Compare live metrics against your baselines, and if drift exceeds thresholds, automatically open an incident, route it to the data owner, and pause affected actions. Run scheduled reevaluations nightly or weekly against your golden datasets and store time series data for audit. Build these monitoring loops proactively. Phase G closes the loop with evolution and retirement. Rotate or retrain models on updated gold datasets and always retest before promoting new versions. Apply retention and deletion policies for expired snapshots and transcripts so you are not hoarding stale data indefinitely. Preserve audit trails and lineage records for compliance because regulators and auditors will ask. This phase is often overlooked, but it is essential. AI models do not last forever. Data ages, requirements change, and new models replace old ones, so plan for graceful retirement from day one. This table is your reference for controls and checks at each promotion gate. You can pause and review if needed. Each gate has specific questions to answer and evidence to produce. Do not skip any of these. These are your quality checkpoints that prevent bad data from reaching production. Region, residency, and cross-border data movement are non-negotiable compliance concerns. Document where prompts and outputs may be processed for Copilot and Power Platform features. Set the default to in-region processing and require explicit approval before enabling overflow processing in another region. Align your mailbox region and environment geography with policy, and define exceptions and purge schedules for any data that crosses boundaries. Use the residency decision tree shown here to guide decisions based on capacity, availability, and overflow allowance. Always default to the most restrictive setting and relax only with documented approval. This RACI chart defines who does what across the data lifecycle. Pause here if you need to and review the roles. Make sure every activity has a clear owner and that no one is working in isolation. Cross-functional collaboration is what makes AI governance work at scale. Operational telemetry and drift detection are your early warning systems. Maintain baseline metrics for every release. Latency at the 95th percentile, success rate, token cost per task, and safety flags per million runs. Continuously compare live metrics against these baselines. If drift exceeds your thresholds, the system should automatically open an incident, route it to the data owner, and pause affected actions. Rerun your evaluation suites nightly or weekly against golden datasets and store the results as time series data for audit. Design these loops to be automatic, not manual. Let's review the AI data ALM lifecycle. Plan, ingest, and prepare, develop and evaluate, stage and approve, deploy and serve, operate and monitor, and evolve and retire. The data flow view traces the path from source systems through curated stores with labels and lineage to feature and embedding builds, indexes and knowledge bases, agents and models with policies, telemetry and feedback loops, and finally, the backlog and retrain cycle. Keep these visuals handy as your architectural reference for data governance across the full AI solution lifecycle. Now let's shift the focus to designing the ALM process for Copilot Studio agents, connectors, and actions. Copilot Studio was where many organizations build their conversational and autonomous AI experiences, and it requires its own tailored ALM strategy. Let's look at what a Copilot Studio solution typically includes. Agents that can be conversational or autonomous, custom connectors, actions, skills, prompt assets supporting Dataverse components, and environment data with application settings. A mature ALM process ensures version control of all these artifacts, clear separation between development, testing, and production, monitoring and validation at each promotion stage, compliance with governance, DLP, and data residency requirements, and a sustainable lifecycle for updates and deprecations. Think of each of these components as a managed artifact that must be tracked, versioned, and governed throughout its lifecycle. Your environment strategies should establish at least 3 core environments. Development is for building and iterating on agents, connectors, and actions. Test is for validating behavior, evaluating prompts, and running regression checks. Production is your stable, approved monitor implementation. Key design principles are never added directly in production, enforce role-based access at each tier, use only managed solutions in test and production, and leverage solution layering to isolate changes. This separation is foundational. It prevents accidental changes from reaching users and gives you clean environments for testing before every promotion. During the development stage, you draft agent scope, intents, and behaviors. Build your actions and prompts, add knowledge sources exclusively in the dev environment, and test agent workflows with edge case prompts to stress test the system. This is your sandbox for experimentation. The key best practice here is to keep development isolated. Knowledge sources should only be added and tested in dev first, never directly in production. The robustness of your agent depends on how thoroughly you challenge it during this stage. The testing stage is where you validate everything before it gets close to production. Validate the reasoning quality and output patterns of your agents. Ensure grounding is reliable and compliant, meaning the agent cites correct and approved sources. Evaluate event-triggered actions to confirm they fire correctly. Run regression tests across all agent topics to catch any regressions from recent changes. Treat this stage as your quality gate. If something does not pass here, it does not move forward. Invest in comprehensive test scenarios that cover real-world usage, not just ideal conditions. In the production stage, deploy your agents via managed solutions, which ensures they are packaged and version controlled. Monitor usage, performance, and safety continuously because AI behavior can shift over time, even without code changes. Apply versioning with planned release cycles so updates are predictable and coordinated. Document change history for traceability so anyone can trace what changed, when, and why. Production is not a set-and-forget environment. It requires ongoing attention. Build monitoring dashboards, set up alerts, and establish a cadence for reviewing agent performance and safety metrics. Connectors are what enable Copilot to interact with external systems, and they need their own ALM discipline. Build connectors only in the development environment. Validate authentication flows to ensure secure connections. Apply DLP policies during the testing stage to prevent data leakage. Publish connectors to production only after full security review, and always track versions with rollback strategies in case something goes wrong. Remember that connectors are a security surface. A poorly governed connector can expose sensitive data or open unexpected attack vectors. Treat them with the same rigor as any security-critical component. Actions are the executable steps that agents trigger, and they follow their own life cycle. It starts with design, where you define the outcome inputs and outputs, then build, implementing the logic using Power Automate, plugins or external APIs, validate to confirm correct action sequencing and error handling, promote through dev, tests, and production via managed solutions, and finally monitor to track success and failure rates and performance metrics. Pay close attention to error handling in actions because a failed action in production can break the user experience. Configuration drift is one of the biggest risks in Copilot deployments, so consistency is key. Use source control as your safety net by exporting solution packages and storing them in repositories. Track all changes to agents, connectors, and actions through a strong change management process. Use tools like Visual Studio Code for connector development and implement a regular release cadence with an emergency patch path. Always include rollback and user change management plans to ensure stability and control. ALM must align with your enterprise governance rules. The key controls to enforce include DLP policy enforcement, environment-specific connector rules, data residency restrictions, use of enterprise-approved knowledge sources, review gates for safety, quality, and ethical risk, and monitoring dashboards for agent behavior. Governance is not a one-time setup, it's an ongoing practice. So regularly review your DLP policies, connector rules, and knowledge source approvals to make sure they stay current as your organization evolves. Monitoring and continuous improvement close the loop on your Copilot Studio ALM process. Key monitoring signals include agent session success rate, action execution health, connector performance, prompt regression, or quality changes over time, and user satisfaction insights. The continuous improvement loop follows a clear cycle. Monitor, analyze, improve, release, validate, and back to monitor. Do not treat deployment as the finish line. The real value of ALM comes from this continuous cycle of observation, analysis, and improvement. Now let's turn to designing the ALM process for Microsoft Foundry agents. A multi-environment model is essential for isolating agent development from production workloads. In development, you handle agent design experimentation, prompt testing, connector configuration, and integration prototypes. In test, you focus on regression testing, scenario validation, integration logic, behavior evaluation, and action safety checks. In production, you serve fully validated, versioned agents to end users at scale with monitoring enabled. Promotion gates control the transitions between these environments. The best practice is to make each environment as independent as possible. Cross-environment dependencies create risk and complicate troubleshooting. Microsoft Foundry agents consist of modular components that must each be governed and versioned independently. These include agent logic and orchestration, prompts and behavioral rules, action handlers and workflows, data and grounding configurations, security and permission mappings, connectors and external integrations, and policies and safety controls. Your versioning principles should treat each agent as a versioned artifact, maintain immutable releases for production, document every change with change logs, and promote only version bundles across environments. The first promotion gate from dev to test ensures that agents are safe and ready for validation. At this gate, verify functional validation of core behaviors, complete the initial safety and guardrail checks, confirm data source mappings are correct, review action and connector configurations, and perform code or prompt quality reviews. Think of this gate as your first quality filter. It does not need to be as rigorous as the production gate, but it should catch fundamental issues early. Failing fast in dev to test is much cheaper than discovering problems in production. The second promotion gate from test to production is your most rigorous checkpoint. It requires completion of regression tests, approval of data access, and policy compliance, assessment of performance and cost, human validation of agent reasoning, and full documentation of version dependencies, and also risk analysis. Human validation of agent reasoning is especially important. Automated tests catch many issues, but a human reviewer can spot subtle problems in how the agent reasons through complex scenarios. Don't skip this step even when you are under pressure to ship faster. This gate requirements matrix gives you a clear view of what is required versus recommended at each promotion gate. For dev to test, functional validation and documentation are required, while compliance, safety, and performance checks are recommended. Foundry agents rely on data from controlled environments, and your ALM process must enforce strict data governance. This means data residency requirements, usage of only approved data sources, role-based access controls, separation of production secrets from development artifacts, policy enforcement for connectors and external calls, and secure identity management for all agent actions. A centralized governance strategy ensures consistency and reduces operational risk. Pay special attention to secret management. Production API keys and credentials must never appear in development environments. Use environment-specific vaults and rotate secrets regularly. Foundry supports controlled deployments through solution packaging, automated or manual deployment pipelines, and configuration as code where applicable. You should implement deployment automation to reduce human error, version rollback procedures for quick recovery, release calendars and change freezes to coordinate across teams, and production-ready validation templates to standardize the pre-deployment checks. The release pipeline moves through authoring, packaging, validation, deployment, monitoring, and optimization. Automation is your friend here. The more you automate, the more repeatable and reliable your deployments become. Ongoing operations for Foundry agents require comprehensive monitoring across several dimensions: runtime telemetry analysis, safety and guardrail event review, error and failure investigations, reasoning quality assessments, action execution auditing, user feedback loops, and cost and performance optimization. Oof, that was a long list, but these insights fit directly into the enhancement cycle for future versions. Build a culture where monitoring data drives decisions. Every anomaly detected, every piece of user feedback collected, and every cost spike analyzed should inform the next iteration of your agents, and that is how you achieve true continuous improvements. Now we're moving next to one of the most complex areas, designing the ALM process for custom AI models. Unlike pre-built AI features, custom models introduce unique challenges like data drift, model drift, regulatory alignment, and high-impact deployment risks. A strong ALM process for custom AI models rests on 4 pillars. Consistency ensures documented development, testing, validation, and deployment steps for every model. Compliance protects sensitive data, PII, and industry-specific requirements across iterations. Repeatability provides predictable retraining and redeployment with clear version histories and evaluation criteria. Operational readiness delivers runtime monitoring, governance logs, and rollback plans for business resilience. These 4 pillars should guide every decision you make about model lifecycle management. If any pillar is weak, the entire process is at risk. The environment strategy involves 3 key environments: development, test, and production. Development is for experimentation, prompt and model variant testing, and data preprocessing pipelines. Test is for evaluation datasets, error and edge case testing, stress tests, and failover validation. Production holds stable, approved model versions with monitoring and rollback controls. Between these, you have 2 promotion gates. Gate 1 ensures evaluation and safety checks before moving from dev to test, and Gate 2 ensures performance governance and cost approval before reaching production. So never shortcut these gates under deadline pressure. The plan and design phase establishes your foundation. Define the business use case, success criteria, and constraints upfront. Identify necessary data sources, governance rules, and privacy boundaries before anyone starts building. Document the intended model behavior, including its limitations and failure paths. This planning phase is where you prevent costly downstream mistakes. A model built without clear success criteria cannot be properly evaluated. A model designed without understanding its failure paths cannot be safely deployed. Invest some time here, and you save a lot more time later in the life cycle. Data preparation is where you build the foundation for model quality. Establish data contracts and schema standards so everyone agrees on what the data looks like and means. Build curated datasets for training and golden evaluation datasets for consistent benchmarking. Use versioned data pipelines to prevent drift and ensure reproducibility, so the same inputs always produce the same outputs. Golden datasets are one of your most valuable assets. They are your objective truth for measuring model performance over time. Protect them, version them, and never let them be modified without governance approval. Model development involves building, fine-tuning, or incorporating bring-your-own model components. Apply responsible AI requirements throughout. Fairness, clarity, consistency, and safe response patterns are not optional add-ons but core design principles. Maintain detailed metadata, including hyperparameters, training, data versions, and environment configuration snapshots. Metadata is what makes your models reproducible and auditable. If you cannot answer the question what exactly went into this model, then you cannot confidently deploy it or troubleshoot it later. Build traceability into your development process from the very first iteration. Evaluation and approval is your quality checkpoints. Validate accuracy, relevance, reliability, and failure handling. Evaluate cost factors like token usage and compute cost, plus latency and throughput, under realistic conditions. Check for safety issues including toxicity, hallucinations, and policy violations, and produce a model card that documents metrics, constraints, and recommended usage boundaries. The model card is your model's resume. It tells stakeholders exactly what the model can and cannot do, under what conditions, and with what level of confidence. Make it thorough, honest, and accessible to both technical and non-technical audiences. Deployment means promoting your model through managed deployment artifacts. Use model registries that support version locking and rollback paths so you can always revert to a known good version if something goes wrong. Enforce access control, encryption, and runtime audit logging to maintain security and compliance throughout production operations. Your best practice is to make every deployment reversible. If you cannot roll back a model deployment within minutes, your deployment process needs improvement. Speed of rollback directly determines the blast radius of any production issue. Monitoring and optimization keep your model performing well over time. Track telemetry, including latency, error frequency, safety blocks, and user satisfaction signals. Detect model drift when output deviates from expected performance baselines. When drift is detected, trigger retraining cycles with updated data to bring the model back into alignment. Model drift is inevitable. Data distributions change, user behavior evolves, and the world itself shifts. The question is not whether drift will happen, but how quickly you detect and respond to it. Build your monitoring to catch drift early before users notice. When a model no longer meets accuracy, safety, cost, or business expectations, it is time for retirement. Decommission the version cleanly, archive all data, artifacts, and evaluation logs, and document a clear transition plan to the next model version. Retirement is not a failure. It's a natural and expected part of the model lifecycle. Plan for it from the beginning. Having a documented transition path ensures continuity for your users and your business. The worst outcome is a model that should have been retired but was not because nobody planned for the handoff. Governance and compliance requirements for custom models are extensive. Enforce data residency and region boundaries so data stays where regulations require. Apply sensitivity labeling to all training and evaluation datasets. Establish a clear policy for allowable external models and data sources. Make sure you put guardrails in place for prompts, grounding data, and action policies. Maintain transparent audit trails for every deployment. These are not nice-to-haves, they are requirements that regulators, auditors, and legal teams will check. Build compliance into your architecture from day one rather than retrofitting it later at much greater cost. Effective monitoring for custom models requires tracking real-time KPIs, including accuracy, latency, cost, throughput, and task success. Implement drift detection to catch changes in input data distribution or output quality before they become critical. Monitor for safety issues like inappropriate or policy-violating outputs. Analyze user behavior patterns such as reduction in reprompts and consistent satisfaction trends. These monitoring dimensions give you a comprehensive view of model health. A model can be accurate but too slow, or fast but drifting on safety. You need the full picture to make informed operational decisions. Here's your responsibility checklist for custom AI models. Define model development standards so everyone follows the same process. Govern access, secrets, connectors, and data boundaries to prevent unauthorized changes. Maintain comprehensive ALM documentation, including model cards, data contracts, and risk assessments. Establish monitoring dashboards, retraining triggers, and failure escalation flows. Collaborate closely with security, compliance, and data teams. You are the orchestrator of this entire process. You not do everything yourself, but you make sure everything gets done. This is the essence of the role. Now let's talk about designing the ALM process for AI in Dynamics 365 Finance and Supply Chain applications. Your environment strategy defines 3 environments: Dev for building and iterating AI models, prompts, orchestration logic, and integrations; Test for validating with safe, anonymized production-like data and performing regression checks; and Production for executing approved AI capabilities in live financial and supply chain workloads. Key requirements include no direct edits in production ever, using environment variables for endpoints, model names, and connection strings, and maintaining separate data sources, including synthetic datasets for safe testing. Synthetic data is your secret weapon for testing financial AI without exposing real financial records. Data contracts for finance and supply chain AI must define the financial and operational entities the model requires, valid ranges, constraints, and business rules, sensitivity labels for financial and personally identifiable data, and schema version identifiers aligned with ALM promotion gates. For training and evaluation data, build curated datasets in Dev and Gold datasets in Test. Keep them versioned and immutable once promoted. Document all data sources, transformations, and assumptions. Financial data carries extra sensitivity. Every data contract must explicitly address regulatory requirements like audit retention, access controls, and cross-border transfer restrictions. Model development in this context produces several key work products: model architecture, hyperparameters like learning rate and batch size, training configuration, performance metrics, and business constraints with output expectations. For prompts and Copilot configuration, ensure prompts reflect ERP terminology, policies, roles, and business context. Align terminology with finance and supply chain metadata, such as vendor, ledger, work order, and production order. Ensure you validate prompt behavior through scenario-based testing. Domain-specific language matters enormously here. A prompt that uses generic terms instead of ERP-specific terminology will confuse users and produce unreliable outputs. The promotion gates follow a structured 2-gate process. Gate 1 from dev to test requires completed data profiling, documented training and prompt logic, and passing initial quality and safety evaluations. Gate 2 from test to production is comprehensive. Model evaluation thresholds must be met for accuracy, relevancy, and stability. There must be no bias or unsafe output in validation scenarios. Performance must be verified under ERP workload constraints. security, compliance, and data residency reviews must be completed, and the deployment package must be approved by architecture and governance teams. ERP workload constraints make Gate 2 especially critical. For deployment, package AI models, prompts, knowledge assets, and automation flows into versioned releases. Use managed solutions or automated pipelines to ensure predictable deployments every time. Your release readiness checklist should include finalized model and prompt versions, configured environment variables, documented evaluation results from both synthetic and real data, backout and rollback plans, and activated monitoring dashboards. Treat this checklist as mandatory. In financial systems, a failed deployment can disrupt critical business processes like journal posting or purchase order approvals. The stakes are too high for shortcuts. Monitoring in Dynamics 365, Finance and Supply Chain covers operational tracking of latency, success rates, exception rates, prediction drift, data drift, and user feedback. Risk and compliance controls enforce data residency, sensitivity labeling, DLP rules, and guardrails for critical business processes. The continuous improvement loop captures telemetry, identifies drift or inefficiencies, retrains or refines prompts and models, and reevaluates in the test environment, and then promotes upgraded versions through ALM gates. Prediction drift in financial systems can mean incorrect forecasts or misclassified transactions. The business impact is immediate and measurable, so monitor aggressively. This architecture and environment flow diagram shows how AI components progress across dev, test, and production. The controlled progression between these environments is what prevents experimental or untested AI from reaching your live financial and supply chain systems. Now let's explore the ALM process for AI in Dynamics 365 customer service and customer engagement applications. The key ALM goals for AI in Dynamics 365 customer service and engagement include maintaining consistent and predictable AI behavior across all environments, enforcing governance for data, prompts, models, and automations, providing safe deployment paths with rollback capability, and supporting multi-app orchestration across customer service, sales insight, customer insights, and field service. That ensures compliance, responsible AI behavior, and auditability, and enabling continuous improvement is driven by telemetry. The multi-app orchestration aspect is what makes this particularly challenging. AI behavior must be consistent across apps that share customer data but have different workflows. The AI assets you need to include in ALM for customer-facing applications are extensive: Copilot prompts and agent behaviors, knowledge sources and semantic indexing configurations, AI model configurations for classification, summarization, extraction, and prediction, Power Automate flows and plugins used by AI actions, data contracts and customer interaction schemas, system messages, routing rules, context rules, and conversation boosters, plus environment variable sets for API keys, model endpoints, and vector index references. Every one of these assets can affect customer experience. A misconfigured routing rule or outdated knowledge source can lead to frustrated customers and loss of trust. The environment strategy recommends 4 tiers for customer-facing AI: development for building and iterating prompts, workflows, data mappings, and orchestration logic; test for validating AI behavior with realistic datasets and running regression tests on summarization, case resolution, and classification accuracy; pre-production for business acceptance testing, performance validation, safety, compliance, and integration testing with live-like customer service queues; and finally, production for serving validated AI features with controlled deployment and continuous monitoring. The pre-production tier is especially valuable for customer-facing AI because it lets you test with realistic service scenarios before going live. Governance and compliance for customer-facing AI demands special attention. Responsible AI controls must ensure prompts cannot trigger disclosure of sensitive customer information. Enforce least privileged data access for all AI features. Make sure you apply DLP policies and sensitivity labels across every environment. And document model limitations and mitigation plans openly. For audit and traceability, track prompt version, decision logs, mapping changes, and agent updates. Make sure you establish a change advisory board with reviews for high-risk AI releases. For data residency, ensure all data processed by AI assistants complies with regional requirements and avoid unapproved external knowledge sources. Customer data trust is paramount. So let's review. You now have the knowledge to design ALM processes for AI components, including datasets, prompts, and models across multiple Microsoft technologies. You can establish governance, security, and monitoring across environments from dev through production. And you can ensure consistent, compliant AI behavior throughout the entire lifecycle from development to production. These ALM skills are what differentiate a well-governed AI deployment from a risky one. Take these frameworks back to your organization and start applying them. We've covered quite a lot in this session. There are many ways to continue your learning journey. Keep the momentum going by exploring the rest of the videos in this course or discovering your next favorite topic on Microsoft Learn at aka.ms/learn. Thank you for watching, and remember, building AI responsibly is just as important as building it intelligently.